Kia ora everybody, welcome to the second in our series of Super Home Movement webinars focusing on design of super homes. And today our topic is windows, and there's a number of esteemed guests that will be presenting. We have, first of all, I'm Bob Burnett. Bob Burnett Architecture is my business. I'm a designer. We have Darren Valentine from Metro Glass. Warm welcome to Darren. Been participants for quite a wee while, actively participating in the super home movement, Metro Glass, and recently we're delighted that they've recently become silver partners. So happy to be working more closely involved with Metro Glass. We have Andrew Krupa from Kaufman Windows and Martin Ball from NK Windows, who will both be talking about their windows and what they do. So kind of the overarching, one of the themes of today is looking at overheating and ways of avoiding overheating and what we can do to with windows to mitigate overheating, because it's something that's often overlooked, and it's actually becoming more and more a big problem. And we're living in a warming climate. It's only going to get worse with climate change. So we need to be thinking about designing windows properly and homes in general to avoid overheating. It sounds like a funny thing to be talking about when we're just coming into winter and it's freezing cold, but that's what we're going to be talking about, among other things. So I'm going to talk about sort of the overarching design aspects when it comes to windows and how it's so important to the design, not just technically, but to the look and feel of a home. And I think the winning combination is those two things: the thermal performance, all the technical aspects, and the architecture, and having something that's beautiful. So I'm going to digress a little bit on that track, and then the other guests will be talking more about the technical stuff. So I think we might just go to the presentation now. So yeah. Thanks to all of our sponsors. So JIB and Brands are our main supporters. Christchurch City Council and Queenstown Lakes District Council have also supported us with some funds for our design guides, which we're busily working on, and getting lots of really great people involved in that, interviewing people, experts in different fields. I think we've already done some of you window guys, so that's good. Yeah, they're all our partners. So first of all, design, so important. You'd expect me to say that because I'm a designer, but yeah, everything is influenced by design. And our series of webinars, each one, whether it's ventilation, whether it's materials, whatever it is we're talking about, I think ventilation is the next one, we'll be talking about how design influences those things, and how integrated design is really important from an early stage. Frames, obviously, Martin and Andrew will talk about the frames and the different options there. Glazing, Darren, he's the expert on glazing, obviously, Metro Glass. Installation, Dan Saunders from Dan Saunders Construction will be joining us online. He's out of town today, but he's going to talk to us about the buildability and just the way we're installing windows, a little bit different, or probably quite a lot different to the building code, and how it's not that hard once you know how to do it. Everything's hard the first time, it's really easy the second time. So overheating, I already mentioned that's what we're going to be, the theme of today, that's what we're going to focus on. So just before I talk about design, I am going to talk a little bit about the technical stuff. So this drawing here is on the left. You've got the typical New Zealand building code, which probably some people, those in the business, will be familiar with. and I see there's quite a few architects online, yeah, and then our super home detail, which we probably came up with, I don't know, 10 years ago now, on the right, almost, and so we got together a group of industry folks, so window people, builder, obviously myself, a designer, pro climber who do the tapes, and we just sat down and we worked out how do we do a decent window detail. So the New Zealand Building Code H1 changes have called for a higher R value for windows, but that's just one aspect. So we're still not joining the dots, or MB aren't joining the dots, because our detail in E2, external moisture, still has the windows installed in this cold cladding cavity. So, and we've got this big chunky piece of aluminium, which is called a wand support bar, which is supporting the window because it's hanging out outside the structural wall. And we've got a massive thermal bridge here, a super highway for the cold to go through. So that's just completely bonkers. So what we have, and that's not the way the rest of the world do it. New Zealand is an anomaly. So what we've decided is that's much better, having the window sitting on the frame. This is a triple glazed PVC window in this detail. And the key thing is we can do away with that support bar, and we can just recess the windows. Super stupid. So we really need to do much better. I think when that detail was created, the building code detail, that was probably not a good detail at the time, back in 2004 or whenever the building code introduced that. That's a long time ago, and it still hasn't changed. So I can remember going to a workshop in Auckland with about a dozen people from all different fields, brands, MB, industry folks, designers, architects, and everybody put their details up on the wall and rated them out of 10. And this building code detail rated very highly for weather tightness. It rated 0 for thermal efficiency. So basically they threw the baby out with the bathwater with the leaky building syndrome and forgot about thermal efficiency. There's a lot of words here. So I think these are the on the top left, these are the 10 things that I'm just thinking from memory, but these are the 10 things that we were sort of considering, and nobody had mentioned aesthetics. So I chipped in and said, well, we need to think about what it looks like, as well as the buildability, the weather tightness, the air tightness, the durability / longevity, performance. Performance can mean many things. You know, it could be acoustic performance, it could be thermal, energy, efficiency, cost, comfort, compliance. So, you know, that there may be others, you know, not necessarily in that order, but that was the things that we were considering when talking about a detail for windows. And I know, to be fair, brands are, India are working on this, and they're close to doing something. I think Martin was saying the other day. So that's really good news. And it's really good that H1's changed, but we just need to start thinking about the building as a system and how everything works together, rather than thinking about little certain details in isolation. And because that doesn't work, we need to think about everything together. So the rest of this slide is really just to jog my memory, and others will talk about double versus triple glazing, thermal spacer, super spacer, good name, PVC, non-conductive frames. You know, timber's non-conductive too. It's just about twice the price of PVC. That's the only problem. Low E is probably your biggest improvement, because, yeah, bang for buck, low E can improve the windows the most. Argon a little bit. So 0.5 is what is required by code now, but you can get windows up to 2 R value. So often people talk about U value, which is just the inverse. So 2 would be 0.5. Yeah. So, and the smaller the number, the better. So 5 would be 2. Yeah. So anyway, I've already talked about recessing the windows, and there's a lot of things that are missing from the building code, and that's really what's driven the super home movement to be a voice for change. The building code, we talk about that being the worst possible house that you're legally allowed to build, and so we know, well, hopefully most of us, because most of the people on this call seem to be industry people. Hopefully most of us know that we need to be doing better. The challenge is probably everybody's on a budget, but the challenge too can be pushback from, I had someone contact me a week or two ago, and or contact through Super Home Movement, and just saying that they're having trouble with their builder and their designer, saying, do we really need to do more insulation? Do we really need to do better recessed windows? Why can't we just do it the same way we've always done it? So even if builders know, if they're haven't got experience with doing things differently, they try and deflect that. And, so you either need to fight for it, or you need to find another person to work with, to be frank. But I mean, to be honest, we shouldn't have to be fighting for a decent home. We should all just get a decent home when it's a new home. But that's where we're at. We've got an industry that says something's good, pretends to be good, and it's not. So yeah, lots of things to think about, and yeah, like I said, this is really just to remind me. Tick it off the list so I don't forget to talk about something. But I mean, why are we looking at this? I think if you just widen your perspective and think about subdivisions, a lot of the time the subdivision is divided up with no consideration for the home, and you might end up, in a lot of cases, a lot of these sites in this block here, north facing, and the street facing north, there could be there would usually be a double garage which blocks the sun to the house. We really need to start thinking about the design of the house in a site-specific way, rather than picking a plan out of a book like a building company does, and then trying to adapt that and add a bit on here and chop a bit off there. I call that a Frankenstein house. And then this magic roof arrives on top, and it looks really ugly. But the other thing is designing for our climate zone. So luckily now we've got 6, and so obviously 0.5 is where we are in Christchurch. I think the North Island climate zones up there, there's a staged introduction of better windows, so they'll just take a little bit longer. So actually, someone shared this photo with me on the left here of a recently built block of townhouses, and someone's put this tinfoil on the inside of their window, and obviously they're not happy with the overheating there. But that's just turned that window into a wall because you can't see out of it. So I think, whoopsie daisy, it's a growing problem, and as houses become more airtight, as they do become inherently and more thermally efficient, it just increases the problem. So these are passive houses on the right here. I've noticed passive houses recently starting to have some shutters on them, which is a good idea. Again, if you're pulling the shutter across, then maybe you're not getting the vision. So unless you've got louvers, which is probably an expensive option. The one down the bottom, much better option, is having large overhangs on the roof. But sometimes that's not enough. Sometimes you might need some horizontal shading as well. So some of these options are good. Again, a little eyebrow shroud for the window. The top left is actually my own house, which we, when we did the earthquake repairs, we did a lot of improvements to the thermal performance. And we always knew the top level was had overheating potential. So it got triple glazing. Because of the height limit on the hill, we weren't able to have a large overhang. It did previously have a sunshade around the windows, but it wasn't enough. So what we've done is we've put these RHS frames, and we're planning to install 6 solar panels there, so that's going to provide some really great shading to that space. So you can do things like that. And we've done bottom left, we've put some surrounds and some extra overhangs. That's the east side, so it's not important, not as important as the west side. So this house here, we were particularly concerned with designing it so it didn't overheat. So there's massive overhangs, there's various shading devices, and a 2-story house, but it has shading, a little eyebrow for the lower level as well, which is often something that's missing with a 2-story house. More difficult to get the shading to both levels. So the other things you can do is you could add a tree. So this house here, actually this was designed as a passive house, and included in the passive house modelling was the tree that we planted, a deciduous tree, so that we could get shading to an area that we were concerned about down on the right hand side that didn't have the same level of shading as the rest of the house. We also had these pergola, these legs that come out to take some shading that was in the design and wasn't put on by the builder, and they were just leaving that until later. But apparently that house, it's got triple glazed windows, UPVC windows. Apparently it works perfectly and it doesn't overheat. And the owners are very happy with that. So another aspect of this design is, if you look on the top right here, the cross section, whoops, it's a bit sensitive, my clicker. We've got a series of clustery windows where we can, and some of them, there's a handful of windows there, and some of them are electrically openable. So we can get a bit of a stack effect going here for cross ventilation, which, you know, even in an airtight passive house, it's quite a pleasant thing to have some nice natural ventilation, as well as mechanical ventilation for when it's too cold outside, or when that's not going to work so well. Yeah, that's mainly facing, most of the glazing is facing west in that open plan area, living dining kitchen area with a high roof. So that's why we were concerned and looking at ways that we could deal with any potential overheating. So windows have probably one of the biggest influences on the look of the build, and maybe other than the roof, you know, the roof is fundamental too, but this is probably a house that's several hundred years old from Japan, and it's got the south elevation, which in northern hemisphere, obviously, you know, it's the other way around. That's going to be the sunny side. A lot of glass on the north, which would be our south side. Very little glass. So the Japanese, traditionally, their method of construction is post and beam. So basically, there's no walls, and you know, in the very old homes, there was a lot of wooden shutters and shoji screens and Fusima screens. So basically, you can just shift the walls around with shutters. And then later, if you look on the top left, glazing was introduced, but it's still got this really interesting feel of openness. And kyokai, that's sort of a word that sort of means the way in which space is articulated, and sort of kind of like the blurring of boundaries, and how you can have the inside you can have sort of this flow from the inside and this transition from the inside to the outside. And that's something that we see in a lot of Kiwi homes because we've got such a wonderful outdoors and often we've got a beautiful view. So it's sort of a little bit at loggerheads with the idea of thermal performance and protecting ourselves from the elements. And in its most basic, a window is just keeping the weather out and keeping the outside out. And but if we were going to take that to its absolute extreme, we'd have very small windows or we'd have no windows. But that wouldn't be a pleasant building. So so this is a house that we've designed for a client where we use these sort of themes, and so there's a lot of glazing, but there's a lot of protection from overheating too. So large an engawa, which is basically what they call a veranda. So we've got very large overhangs. We've got a lot of glazing, so we need that. And it's what I call Japandi. So we've got this sort of very light, bright, natural materials, quite organic, quite sort of biophilic. But again, here in this north elevation, we've got an additional eyebrow over the windows for shading on the upper level. This house here too, if you're going to introduce shading elements, they've got to be at the right height. So this is another example of an over height. So it's from 3.5 meters. So we've got this second eave or eyebrow at probably 2.4. So the height as well as the width of the shading element is important. The higher you go, the wider you need to be, or you need to introduce some additional shading like there is in this design here. So, but this is kind of, again, this idea of almost an outdoor room because it's got an absolutely fantastic view. But there's the ability to close this house down or open it up. This is a design that's under construction at the moment. So there's again these massive overhanging roofs and a veranda in this case. This house actually has sort of a multi-layered design. So there's high-level windows, there's a higher ceiling in the main kitchen, living, dining area, and then some of the other spaces, the entrance, and then the bedrooms have 3.5 ceiling. So there's this ability to get some additional high-level light just for this really awesome quality of light, and that's important. And it's just really enjoyable. Sometimes we do a house and people comment that they're delighted by the light, but then that's something that they probably weren't thinking about and weren't expecting. And this house, the entry hall is sort of like a place where they can hang their art, and there's a really nice quality of light in there because you're getting south light into that space. So that's just the other side of that house. Now this house here is a house that I lived in for 7 years while I was waiting for my earthquake repairs to be done. And Martin from NK Windows replaced some of the windows in this house with some pretty good windows with low E extreme glass, I think, and made a huge difference. And it actually looked, it was really easy to do. It actually looked quite in keeping. So we put this transom through the middle. So it looked sort of not unlike the double hung sash, sliding sash windows of 1906 when this villa was built. So it was really cool. And then we actually managed to keep some of the LED lights. I mean, that's still got the original windows, but we kept some of the LED lights when we replaced those windows. Really quick, it took I think a day and a half to replace about 10 windows. We did 3 bedrooms. I think a really important thing is retrofitting houses and doing it properly. And, windows is a big thing. So if you look at this house, in some ways we've sort of gone backwards because the windows were originally recessed back in the day. And so we've kind of gone backwards now with our flush windows, with the way the building code tells us to do it. So that house is going to be removed in a couple of 3 months, and then taken, and someone's going to finish off the renovation of that house on another site in North Canterbury. And then we're going to build 4 townhouses, and these townhouses have been designed for light and sun. So they're separated from, they're kind of semi-detached. So each of these 4 homes, I mean the front one and the back one are standalone. The middle 2 really only attached by the garages, but the garage, and then space for, you can sort of see it in this image here, so space so you can get light all day into the homes. If this was a typical developer, they'd have filled in the gaps between each house, and there would be 7 units there instead of 4. So we're just thinking about the best possible living environment for people and making places that are delightful to live in, rather than, people before profit, health before wealth. So inside these homes, they're sort of they're all actually semi 2-story. So there is a large living space, open plan living space with a sort of a over height roof, the opportunity to get some nice glazing and some nice light into the living spaces. So just quickly look at what I've forgotten to talk about, which is probably a lot, but it's about time to hand over. Yeah, the other things I had on my list, maybe we go back to the room and I can introduce the next speaker shortly, but the other thing I had was just the importance of integrated design. Some things I haven't talked about is acoustics, security. Acoustics is really inherently dealt with by having better thermal performance. The triple glazed UPVC windows are great for acoustics. The functionality, so I mean, perhaps you guys can talk about the tilt and turn. And, the great thing about tilt and turn is you can open, if you design them well, you can open the window and clean it from the inside, but also ventilation. And they're very airtight because of those mechanisms. Oh, last thing, earthquake resilience. So just designing correct window proportions so that you've got good structural bracing. So a lot of the homes we do, they have 150 or 200% of NBS, new building standard. It's not difficult to get to that level, and it's not expensive. It's just a matter of getting your glazing proportions right and then the right amount of solid wall where you need it. And then, perhaps the other piece in terms of earthquake resilience is how the windows stand up. Maybe we need a better tolerance around the windows for movement in an earthquake. Maybe installing them with double-sided tapes is better than the foam, which isn't going to be great in an earthquake. And the biggest thing I saw with windows in the earthquakes in Christchurch was the miters separating, so they're just pulling apart at the corners. And I saw buildings where the glass just bubbled. It was an amazing amount of stress on the windows. Anyway, I'll hand over to Darren from Metro Glass to talk about the glass, and then we'll take questions at the end, probably 10, hopefully 5 or 10 minutes for questions at the end. Okay, there we go.
Awesome. Yeah, so as Bob said, my name's Darren. I've been with Metro Glass for 10 years, and what I really enjoy is helping people make good decisions with the glass that they use in their homes or in their buildings. And so with that, I really appreciate the opportunity to talk to you here today about glass. So very briefly, who's Metro Glass? Well, it's all there on the paper, but what do? We're basically here to supply glass to the construction industry supply service with that. And a big part of what I do is then supply the technical support. So as you can see, we've got representation right up and down the country. And in each of those areas, we do have people that are experienced in both servicing and with the knowledge of how the glass works. Why are we involved? Well, basically, we want to encourage people to invest in energy efficiency. And I choose the word invest because not only does it lower your carbon footprint, but it also lessens the running cost of your home, gives better health, and therefore you might find yourself at work more. I don't know if that's a good thing or not, but you may do, which means you've got the opportunity to make a bit more money. Your family's more healthy. And the other important consideration is comfort. So being comfortable in your home is a very important thing as well. Quite often underrated. Very briefly, in terms of what low-E glass is, it's a silver metallic coating that gets applied to the glass. As time's progressed, they've got more and more innovative with what they can do with these coatings. So initially they were hard coat pyrolytics, and they had, they were better than clear glass, but now as time's gone on, they've managed to integrate different things in and give you more ability to adjust your windows. There can be up to 17 layers in the modern soft low-E coating now. And yeah, not only do they do insulative, they do solar control, which we're going to touch upon shortly, and as well they can offer different aesthetics in terms of tint. So yeah, it's I find it really enjoyable as I watch these progress. I mean, the latest innovation has also been reflectivity, where you can get the privacy aspect as well, which becomes important when you're getting into medium and high density housing. Had some people in the other day that also wanted it for reducing the glare effect. As I say, it just means we've got more options. And our job is to listen, then provide the best options. The anatomy of an insulated glass unit, I mean, we had a group through our factory yesterday and they thought it was going to be about a 15-20 minute tour, and what they discovered is there's a whole lot of things that go into an insulated glass unit, and I won't go through all the layout there, but you can see there's various pieces, not only those two pieces of glass, there's different types of seals, there's desiccant, there's gas, there's the low-E coating. What I do point out is that becomes very important in conversations is the surface location. So it's an industry standard that the outer face of a piece of glass is surface 1, and then you just progress through your count depending on how many panes of glass you've got. So for example, if you look at the bottom, the triple glazing has 6 surfaces there, and that becomes important when you start looking at the performance or how you want something if you're trying to get a certain level of performance out of that triple glazing. The other important part is the thermal spaces in terms of they don't actually affect our U rating. So when you see our data in our information, but where they do come into their own, we quite often get requests for people doing calculation or modelling because it's important that they know what the psi value is of our thermal spacer because it does affect the R rating. So another important aspect is we're only one component of the overall window, and that's where Martin and Andrew will come in later with that aspect of it. But obviously we are an important contributor in terms of our windows do need to meet, or our glass does need to meet certain requirements, insulative and otherwise. And so that's where we work as a team as we develop a window system. The other thing is argon gas. There's a few things that are out there in terms of how long it lasts. Basically in our factory we try and target 95% filling. We need to get equal or above 90%. The point that I do make is that when people talk about low-E coatings, they talk about, oh, you've got the XL, so it's going to automatically meet U 1.1, say for zones 5 and 6. Well, no, if you have low-E XL, but you have a 12mm spacer, it won't meet U 1.1. So you've got to take into consideration the thickness of the spacer when you're calculating the U values. And again, that's something where we're readily available to help. It is in most of our data sheets. And so, yeah, if you're at all concerned, don't just take it at face value that that low E coating that you're looking at, which you've seen in the glossy magazine, meets a certain U value. It does, but what you'll see in the fine print is they'll say calculated on a 14 or a 16 mil spacer. And that does become a bit of a challenge sometimes if you've got suites that won't accommodate some of these units that you might require to get the insulative, and that especially comes in with triple glazing as well. As Bob said earlier on, as houses get more and more thermally efficient, they get efficient at keeping the heat in the house. So an important aspect, and that's why they've been developing these low E coatings, is to have more solar control available. It's not the silver bullet solution, but what it does is it helps. And then what is also required is the other aspects that Bob talked about in terms of physical, likes of the eyebrows that he talked about, or landscaping, that sort of thing. But it certainly can provide very good protection. And we have some of the solar, and there is no sweet spot for solar control, is the other thing that we've found. So you can't say lowest is better, it isn't. Sometimes people are looking for a combination of both insulative performance, but they also want either passive heat gain, which becomes a compensation, or else they are wanting to try and lower the amount of overheating. So again, it's our job to listen carefully and then provide solutions. And I'll give you an example, a case in point, just recently. And actually on that slide where you see the 30 degrees in the lamp, then you'll see on the watch it's 24 degrees. That was a recently published photo where, yeah, it was 24 degrees outside, but the heat was building up inside the house, a townhouse, up to 30 degrees, and obviously that just keeps on cycling through. So that sort of evidence is, and we're getting it more and more as people have become more and more aware of it. But going back to that case in point where not only do you look at the low E, you look at the space, the size, you look at the surface location. So if you remember a few slides back, we were talking about surfaces 1, 2, 3, 4, 5, and 6 in a triple glazed unit. What we were asked to do is get a certain insulator value that was targeted, which was U.6, and then also we needed to get a 52% solar factor. And so our standard published document had the 0.6, so we could achieve that. But what we weren't achieving was that 52% solar factor. But what we did, if you looked at the fine print, those results are based on the low E's, the double low E's, one being on surface 2 and one being on surface 4. So what we did is we flipped that unit around so that the low E surface was on surface 3 and 5. And the wonderful thing with low E coatings is that then allowed a bit more passive heat gain to it actually worked out at just about 53%. The reason for that being, it's like tinted glass. You always, with the old school tint, you used to put it on the outside of the window because that was the piece of glass that heated up the most, and then the heat by convection went back to the exterior. Well, it's the reverse effect when you're wanting to put a bit more heat into a house. That low E piece of glass actually warms up a bit more than the other glass. So what you're doing is you're radiating heat into the house and achieving what was required for that job. Just as we may have had that reverse where someone wanted the insulative value, but they didn't want as much heat, so we'd have been wiser putting it back where it originally was and getting better solar heat protection. And then we can work around with other types of solar glass as well that will give less solar heat gain. And that's the wonderful thing. We enjoy doing that. And certainly in this area, we openly invite people when they've got a project to come and start or to talk to us, and we will actually provide specific reports to help you target what you're trying to achieve and help the designer get to where they need to be, rather than taking that generic approach. The other thing that we've found is that we're trying to keep things as simple as possible at the initial approach, because what we don't want to do is frighten people off from making good decisions. We're not sure. Sometimes it feels like people make things overly complicated. So you'll find in our publication, what we've done is we've actually just last week totally revamped our website, and we hope people find it far clearer, because that was one of the, we try to listen to what people say, and I must admit that was a big undertaking, but we've tried to make it easier for people to start, ask a few basic questions, get the direction going, and then if it's the person building that wants more information, great, but then they can also refer whoever's doing their design work to contact us, and we will help get them to where they need to be. So yeah, we think that's a good little value add that we provide as well. Now, the one thing I do want to bring to your attention today, with all these eyebrows, vegetation, hex isolation being put into windows, which effectively makes it a wall, is that when you start doing these sorts of things, you do need to start considering thermal stress breakage. So on the right-hand side of that, there's a hierarchy of risk, and basically the safest way to guard against thermal breakage is to use toughened glass. Now, what is thermal breakage? Basically, if you've got one pane of glass and it's got heat on one part of that same pane, so say it's got direct sunlight, but part of the same pane is also shaded, what happens is the bit that's getting warm expands, whereas the other bit that's still cold in the shade or whatever it is, it remains, it doesn't expand as much. And what can happen is the glass then goes, part of it's moving, part of it's standing still, I'll break. And that is particularly high risk when you've got thick, believe it or not, annealed glass. So what's annealed glass? It's the glass that comes off the float lines before it's had any processing and then toughened. So once we toughen a piece of glass, you can't polish it, you can't drill holes into it, it just automatically breaks. But before that stage, when it's annealed, you can do a whole lot of things with it, which is why it's like that. But certainly you can see down that hierarchy that actually which makes good sense, the wired glass, which not only is annealed glass, it also has metal in it, that if it heats up, you're going to get a more of a dramatic effect with it. That's the only thing that we'd ask that you be very mindful of while you're designing, putting in shading or other means that perhaps could mean you get a temperature variation in that same panel of glass, easily dealt with. That diagram there, it just basically shows the various things that can be used that can actually lead to thermal breakage. So yeah, the whole object today was just to give some brief information. I don't disappear over the hilltops after this presentation, so if there's any follow-up questions or anything, myself and I've got, there's a team at Metro that do this. I'm more than happy to help with any of these glass-related matters. And as you can see, there's a lot that we can do to help a house out in the design for either more insulation, more acoustic, privacy, letting more light in, whatever you're wanting. So with that, that's me done.
Thank you, Darren. And now we'll have Andrew Cripper from Windows. Excellent. I've got some questions for you.
Okay. So my name is Andrew Kruger from Windows. We manufacture windows in Europe and import them here. So they're not standard sizes, they're made to order, so it's typical for New Zealand houses. We've been doing it for the last 7 years, and over this time we found that what Bob was talking and Darren was saying, glass, the shading effect that should be on the outside. There's protection. Once the heat is in, it's too late. So we have this option now available for roller screens. They can operate. You can operate them remotely. You can automate it so they actually screen your window during the day, and when you're not there, and open it up. They have different fabrics to choose from. You can design how much heat, how much light needs to go through. You can act as an insect screen as well. So they can be retrofitted, but the window or the wall has to be able to to design, so it's actually close to the windows. They work really well with European style windows, which often do woods, and we'll talk about it as well. You can still ventilate the house, tilt the window in, and shade it. The windows, in generally, all the European windows are designed to be recessed. That was done a long time. It's typically, like Bob said, used to be all the windows were recessed. It's only recent New Zealand innovation to put the windows outside the wall. And they are designed to insulate across the frame. So all those little pockets of air within the UPVC window, that's designed so more pockets, better insulation. UPVC itself as a material is better insulated than aluminium. And the higher rating you need to achieve for your window after the plastic house, so the more pockets the better, so the windows frames are thicker. The other thing is they need to be that deep to take thicker panes of glass. Triple glazing with 80mm spacing, so that's 48mm. Not every frame can take it. But with this triple glazing, you achieve R value of 1.35. That's on the standard frame. If you look at it, if you push that window outside the thermal envelope, you create the bridging. There's a metal bracing inside the frame, so you bypass probably 60% of the insulation of that frame, and you thermal bridging. You can do the same. That same applies to aluminium windows. Doesn't matter what style of the aluminium window it is, or the thermal break. This is one of our standard thermal break. You achieve the same value as UPVC frames, but if you push it out, you bypass that insulation layer altogether. So you have aluminium, which is a great conductor, one of the best conductors, conducting materials, and you conduct the heat or cold straight through, and you get condensation on the frame. So the other thing is those frames, because they are essentially UPVC frames with 2 bits of aluminium on both sides. So they still have to be recessed for structural integrity to take the weight of the glass and reduce the possibility of bending. And you can, with the new sizes of windows being bigger, larger pieces of glass, there's actually a lot of weight on those frames. So recessing them, supporting them all the way around, that provides that structural integrity of the framing. Our advice in general, education is the key. So that's what we're doing today, and it's always free. And you find all the companies quite happy to talk and what they offer, and Super Home movement. There's a lot of information online. There's no reason to say, oh, I'm just buying something. And have a look at the specification. When you're just buying the windows or house, whatever you're designing it, don't just say, oh, we want triple glaze windows or double glaze. Have a look what it is, what size it is, where the frames are supplied, will be able to support it, how that is installed. But maybe your 0.5 R value for the windows, it actually won't be achieved when you install them outside the thermal envelope. So all those little details do matter. And this Super Home, all the suppliers, all the designers and builders, they all think the same way. So if you have all the three parties and yourself as a homeowner or developer talk about the same thing, you achieve easily what you want within the budget. There's always a budget to consider, so have a look around and have different quotes, because quite often you find that windows that are better performing not necessarily have to be expensive. In Europe, PVC windows have been around for a long time now, probably since 40s, and they are the standard. Aluminium windows that are shown, that's actually a premium product. It's always more expensive because there's more into it. The thermal and break inside, it actually takes quite a bit to design, so the window performs well. And you have another option with this, different colors, more options, glass. It's always the highest standard glazing. And when you think about it, single glazing, nobody would buy especially in the South Island, single glazed house anymore. always people, that's the coldest spot in the house. So double glazing is great, but good performing double glazing or good performing triple glazing, it will be the way of the future. So when you look at selling a house later on, where somebody will live in this house, they will appreciate you putting the thought into it. Maybe smaller house for the same budget, but better performing. And that'll be it.
Thanks, Andrew.
Just like that. Well, hello. My name's Martin Ball from NK Windows, and I'll be probably a little bit briefer than the previous two. They've touched on a lot of the subjects that I would talk about as well, and I 100% agree with pretty much everything they said. So, NK Windows has been around for 24 years. We manufacture PVC windows in New Zealand for the New Zealand market, both renovations and in the new build space. And it's forwards, there we go. I've got a one slide wonder. So when I thought a little bit about today's webinar, one of the things I thought about was what's the stuff that I talk about every day in the showroom with people when they come in and talk about specifically PVC. And probably the number one topic is the effect of UV on PVC frames in New Zealand. So the good news there is that the clever German chemists solved that quite a few years ago, over 20 years ago. PVC's been used in production with titanium dioxide, which is a stabilizer. So absolutely, if you're looking at buying, considering PVC windows for your build, whether you're getting them locally or importing, just make sure that you've got that titanium dioxide content in there, which will deal with, acts like a sun cream, so it gets rid of the issues of flaking or discoloration. Probably other conversation I have with customers, and I spend a lot of time with glass, and I'll get to that in a second, but I spend a lot of time talking about hardware. In New Zealand, we're very traditional around our outwards opening windows, but there's pros and cons of those outwards opening windows. I guess the beauty of outwards opening windows is you don't have to worry so much about the interior because the sashes are swinging out. So they're more familiar, easy to address internally, whereas inwards opening, typically because of the tilt mechanisms, they've got great gearbox systems in them, and that allows greater security and airtightness as well. So they do have some distinct advantages. And I think Andrew's slide with the exterior screens was another good example of where an inwards opening window works really well, because you can put shading and things on the outside and still operate the window. Bug screens are another good example of where inwards opening windows work really well. Dan's coming up shortly. I won't steal his thunder around kind of the window to wall connection. I'm sure he'll talk about that. But yeah, certainly recessing, thermal modelling we've done indicates 15 to 20% gain in thermal performance. As Bob mentioned, MB is looking at a standard building code recess detail. It won't come in quite far enough. So with the windows that have got the exterior fins on, they're going to still sit those out over the framing and the RAD board, but they're designing flashing systems that will come out over the cavity of cladding systems. And they're still, unfortunately, talking about sill trays, so there will be some thermal bridging issues in there. So again, less than ideal, but starting to move in the right direction into the rest of the world. In terms of installing into the window, taping is absolutely critical, and Dan will talk a bit more about that, but certainly using a good quality breathable tape. It is a bit of a trick, but once your builders get the technique right, it's pretty straightforward. And the good news over the last few years is the companies that provide those wraps and tapes are more than willing to come on site and train your building teams. Foam is important as well, so good quality expanding. We tend to use polyurethane expanding foam. You do need a bit of an air gap between the frame and the building structure to make sure you get full activation, and the trick is to make sure you get good depth through the frame as well. Just some rules of thumb in terms of double glazing versus triple glazing. Yeah, good triple glazing almost doubles the glass performance compared to double glazing. Adds typically 20% to the price of a house lot of windows. So there's a reasonable sort of value trade-off there. But one of the tricks is with the triple glazing, as and Andrew mentioned, that you do need the deeper frames, because typically 18mm is about optimal for an air gap. It depends a little bit on surface coatings on glass and a few other things, but the standard we offer typically a 70mm 5-chamber system, so good double glazing, slightly less than optimal triple glazing, but still very good. And Bob asked me to comment a little bit on kind of alternative frame materials as well, and that needs to be a reasonably balanced conversation. I was interested to see Andrew's comments around the quality, the thermal qualities now of some of the aluminium frames that you can get hold of. Yeah, typically the New Zealand frame is fairly poor thermally, but certainly go well in terms of a good choice for colours. And we also recognise that the aluminium systems that have been designed for New Zealand situations incorporate a lot of design features that homeowners like as well, and sometimes that's hard to mimic in European systems. The classic one is the opening sash and the slider. And they're very good structural aluminium as well. So typically get bigger openings at a lower price. PVC, good thermally, typically less colour options, although that's getting a lot easier. There's quite a wide choice in multi-surface as well. So there's a wide choice of colours coming out of Europe now, both foils and aluminium clip-ons. And one of the joys of PVC is multi-surface, so certainly a trend in Europe is to have multi-surface finishes, so maybe a wood grain on the interior and a colour on the exterior is much more common if you don't want to be looking at white frames. And they're just typically less familiar design, so we make a lot of progress when homeowners especially come into the showroom, and we can just kind of talk them through what those options are and what some of the design trade-offs. So, inwards opening windows, for example, thinking a little bit more about curtains, blinds, taps, things on the inside of the window that could interfere with the operation. And wood, also very good thermally. I was interested to see some of the data earlier from Darren as well in terms of the impact of spaces and glazing on different wooden frames. It's a very versatile product in terms of configurations. It does have a maintenance component to it, and that's something just to be wary of. As wooden frames get damp, their thermal performance can drop off quite markedly. And yeah, pretty expensive. And I say expensive on a like-for-like basis. So comparing good glazing and good quality hardware, a wooden frame will typically up to twice as much as a PVC frame. So anyway, that's just a couple of comments from me, typical questions and things that people ask about when they come into the showroom and they're looking at something perhaps a little bit different. And I will hand back to, looks like you're on next, so you're closing your intro.
Dan's still online. We might stop sharing and bring Dan on. Where's the Dan? Come in, Dan. He's got it.
Hello. Can you hear me?
It's unmuted. There you go.
Welcome, Dan.
G'day.
Basically, Dan, I just wanted to introduce you to tell us that it's not that hard to install recessed windows. You shouldn't be scared of it, because the biggest problem I see is people following the building code detail because they're scared it's going to leak and they're going to get in trouble.
Yeah, no, I've got my camera. It should be going, but I'm not too sure you can't see me, but that's okay. So from my point of view, the change to the building code, it happened with the H1 and the thermal breaks in windows and stuff like that. But overall, the change is going to happen. So I think, why are we waiting for legislation to be doing things better? From our point of view, it's we've been recessing windows for many years now, so it's how we'll always do it. We're not going to go back. There's just no need for it. So with the H1 changes, adding the thermal breaks or making them more mandatory across the country, what should have happened too was E2 should have been changed as well to make it, mandatory to recess the windows in, because what will be happening with, say, a standard brick house with a vented cavity, the thermal break in the aluminium window won't be protected. And that's things like that are being missed with installing windows. So you're still going to get that thermal bridge going from inside and out. I've seen people talk about still having condensation with thermally broken aluminium windows. So just getting it right when you recess it in is very, very important. So including tapes. I'll take it back another step back. Is when you install a window, whether it's a standard aluminium with a timber reveal or a UPVC or a European aluminium window, the window has to go in plumb and level. So that doesn't change. Where you put it in the wall cavity, again, it's important to get better performance by recessing it in. So there are clips that the PVC windows have that makes it really, really easy. Getting your head around the different types of flashings that you can use, and ProClimate have some great tapes that are brands appraised to help that as well. So again, as Bob said earlier, the first one, might take a little bit of thinking, but once you've done one, whether there's different claddings involved, it just becomes easier after that, and it becomes a no-brainer. And also when you're thinking about some of the windows that you're putting in, the cost comparison now with European style windows, whether they're imported or manufactured in New Zealand, they are very relative to the thermally broken aluminium ones. So again, it's a no-brainer for me. Why would you put in a subpar product? Because what hasn't been talked about, I don't think today, is the air tightness of these windows. So the PVC European style windows are all airtight. The aluminium New Zealand made windows have the drainage holes and things like that, and they don't seal correctly to allow the air changes in the house or the energy to move in the house. So that's something that's very, very important as well. So we have one of the upcoming jobs that we've got in Redcliffs, where we'll be doing some window installs, and what we'll do is, if people are keen, we'll have a on-site seminar with some installation of these windows as well. So we'll get a group of people around that want to check that out, and we can show people what that's about.
Cool, thanks, Dan. That house, I think, is the house, the one you're talking about, that will be on this year's Super Home Tours on the 20th of July. As an
Absolutely.
Example.
So once we get a little bit closer to the window install on there, we'll send it out through the Super Home movement and invite people to come and have a look. You see how it's done.
Yeah, and good point about air tightness. I think window companies should tell us what the air tightness is as well as the R value. I think that's really important because it has a huge impact and it's not thought about. So there's a couple of questions online, and I think now maybe I'll just invite anybody to ask questions of any of the speakers today. I know we're at about time now, but I think it's important to have some questions that people still have time to hang around. So maybe you guys want to bring your chairs over here a little bit, and we can just sort of shuffle over. Yeah. Who wants to start?
Looks like a glass guy crusade with the glass.
Darren, question?
Putting the lowering surface on the inside surface. Okay, so yeah, that's the danger when you're going through. So when we're talking the inside, it's surface 3. The soft lowy coatings always go on the inside of the unit, and so when I say inside, it's the inside pane, but on surface 3.
But I think what he's referring to, what you were talking about on the triple glazing unit. So there'll be on that.
Well, that one there
in
is
the middle glass. Surface 4 middle glass when you're talking about reflecting back in.
So surface 4. Okay.
So it's weird.
So the second question. Okay. Yes. Okay. So the second question being thermal stress breakage. I've observed back here. Okay. So effectively, standard practice is to have so you've got an outside exterior pane, a middle pane, and an inner pane. That's the way to best not uncomplicate that. So exterior pane, middle pane, inner pane. The middle pane is quite often left as a nil. The reason for that is because to toughen a middle pane, you're putting extra processing on it that when you've already got 1 to 2 panes already processed, it can start affecting the aesthetic or the you're looking through the glass, you can start seeing distortion, that type of thing. So there are certain circumstances where you would want to toughen that middle pane, being if you could see from and that's something that wasn't discussed earlier on, is there is a thing called a thermal risk assessment report, and that really takes into account looking at a window and saying, what are the risks of a window breaking? Now, quite often, and I have seen it, like we've been doing triple glazing for many years now, and we have a handful of middle pane thermal breaks, because remembering too that middle pane is then not exposed to the same extremes of either the exterior or the internal environment, so that helps it. As well as that, you've got to be more careful. We're very careful with the processing of the glass, because where a thermal break starts is at its weakest point, which can often be, there might be just a small defect on the perimeter edge of that middle pane. And so if you can have that well polished, well processed, then that again helps limit that risk. So the only time I've really seen it is when there hasn't been a thermal risk assessment, which I've got to say isn't common practice. The good news is that we hardly ever see it, even when there hasn't been thermal risk assessment. But what we do find is if there is then one that sneaks through, and quite often you'll find there's been a big overhanging soffit or a wing wall or something that's made part of that unit very, and especially in the orientation of the building, so you'll have real direct sunlight, intense heat, then there'll be shading on part of the window, and yes, that could trigger a thermal breakage. And one of the units we actually did find also, there was, when we took the unit out, there had been a perimeter defect. So it is one of those things where, going back to the original question, I assume the stress, so I'm hoping that answers the question as well as outlines what we can do to mitigate the risk.
Okay, I've got a question for you, Darren.
Yes.
So I love the idea of maybe having different glass options in different windows. Maybe even having some windows triple glazed, some windows double glazed, whatever.
Yeah.
But just does it add a lot to the cost if you have different surface layers with different windows, or is it just a small cost?
It's a small cost when you take it, and the important thing to think about when you're talking cost, don't go and take your window cost and times it by a percentage of what you're told, because the glass is a percentage of that window cost, but it's not the, so that's the other thing we find is people go, oh geez, I'm paying, $100,000 and I'm adding another 10% on for that. So what we do advise, because we sell to window fabricators, we don't sell to customers and directly, and so what we ask them to do is just do the simple maths, which is go and ask for the variation. Because the other thing I'd strongly recommend here is if you're doing triple glazing, but you're only looking at putting one low E coating on there, I'd strongly suggest you actually look at doing double glazing with a high performance low E coating on it, because the performance, when you look at the data, is very small. However, the secret and the source is when you have a triple glazed unit with two low E coatings on it, that's when you start getting the real performance, and that's when you can also start ramping things up or down depending on what the performance is required.
I think my takeaway from today, just listening to you, and sort of I probably know more than the average reader about it. It's really complicated, the glazing options. So I think people are probably just best to talk to you. So it's a matter of not needing to know everything yourself, but knowing who to talk to get the right options.
And what I like about our team is that we're not salespeople, we're scientists in that aspect of the business. Sure, I still do sales, don't get me wrong, but certainly the people that I also refer to, because I've got people, like we've got some very clever people in the technical side of it, and they will just, it's the science, it's the data. So you go to them and the advice you're getting is based purely on the performance. Yeah.
And I think that's the beauty of the super home movement, just knowing.
Nothing, even H1, if you look at the table for the windows when they came in, they actually stipulate the double glazing and triple glazing differences. When you look at it at different ratings, double glazing sometimes it is better, but that's comparing with triple glazing in 12 millimeter spaces, standard glass, or just one low E.
Yeah.
So that's why in Europe there always triple glazing, it will be always two low E's, and it'll be 18 mil space.
And the tables are okay for people just doing standard builds, and what we're trying to do is get people to do better builds. And the fact is, again, it's no big deal for us to also give you the reports on it. It takes a little bit of time. For the money you're spending on that glass, we're happy to give that advice.
So Mei-Ling, question on retrofitting Windows 60's brick veneer house, and I think, yeah, I mean brick veneer sort of looks recessed, but it's not. I think it's similar to probably a liberal house. But maybe Martin, you can answer that question.
Yeah, a couple of different options. There are frame types available that have an extension sill on them that bridges the gap. So typically the ventilator cavity gap between the brick and the main structure of the house, 40-50 mil. So you need to bridge across that so that you get the frame inserted back into the insulation line. It may depend a little bit on what's existing. So if you've got an existing wooden frame, as I think Bob mentioned, sometimes that wooden frame is actually in line with the insulation, and the wooden sill has bridged the gap out onto the. So sometimes actually the answer is to leave the wooden frame and take out the sashes and the glass and insert a new frame into the old wooden frame, and that's probably going to give you the best performance at the least cost. And there are flashing systems as well if you want to go to what we call increasingly what we're doing is what we call deep retrofits, where we take out the entire window frame, rebuild a new frame right inside the insulation layer, and try and do all the taping and foaming as well. That's more difficult because you need access to the cavity around, and there's quite a bit more work on the interior. So it'll depend very much on what you've got now and what sort of frame we can use to insert into it.
It's quite often necessary. People don't want to get rid of that in the frame. For the maintenance issues.
Yeah, I think
It's probably like case basis, but you can design flashing, it's easy.
Yeah, I think window details in interior sections, there's sometimes as many details as there are different types of cladding. The important thing is getting a good designer who knows how to correctly detail the windows and use the right products as well. So that's the key to it. Any more questions? I think we're probably over time, but I'm happy to carry on.
Something we haven't touched is the sustainability of, because a lot of people ask that question. PVC windows, how sustainable they are, and all the European, like all the frames, whether it's manufactured here or overseas, they always come from Europe. So they do recycle a lot of it. You can now get 100% recycled frames. And the latest development, as probably not many people know, you can manufacture PVC out of the pine oil, which is some new developments in Scandinavia.
Yeah, the purist was going to say, what's the most sustainable thing? I'd probably say timber windows, but they're just double the price in New Zealand anyway. So I'm not sure why, but they're just out of most people's budget. I mean, I can probably count on one hand the number of times we've done proper high performance European style timber windows. There's not very many at all, but when you look at the product and how it performs, say, if you compare triple to double glazing, that's more carbon, but the amount of operational carbon that saves over the life of the building, that'll be 10 times the amount of upfront body carbon in that product. So you've got to look at the whole life cycle and how that applies.
I was going to say, no one's got a perfect environmental story either. It's not hard to find articles in Europe where there's deforestation, so they can grow and destroying habitats, so they can grow sustainable forests for window frames, wooden window frames. And then there's some pretty nasty chemicals that you have to treat those frames with so that they don't rot. So low embedded energy in timber frames, typically about a 1/7 of PVC, which is about a 1/7 of aluminium typically, but no one's still as perfect. Yeah, and then the maintenance comes into it too. So you've got to recoat it. That's actually quite, funnily enough, one of the most carbon intensive things is carpet, because it gets replaced several times over the life of the building. It lasts for about 10 or 15 years. And because you're replacing it, it's got the high embodied carbon. It's probably similar with having to maintain anything really, building, repainting it.
There's mental anguish when you get told you've got to go and do the maintenance with
Focus up your weekend.
Well, thanks, guys. I think there's been some really good discussions, and there's always more to talk about. It's just incredible how complex buildings are, and particularly when it comes to windows and how they connect to the rest of the building. So, maybe in the Super Home tours and subsequent webinars, we can carry on the discussions. So thanks for today. Well done.
Thank you for the opportunity.